distinct honor to be able to introduce our speaker. And it starts with a personal story because it was over 20 years ago that Ed Mazaria, who's the founder of Architecture 2030, came to San Luis Obispo. I heard his lecture, and at the time it was a novel concept that buildings are contributing to climate change and environmental degradation. We were blaming industry and transportation and anything else we could, and he said, no, look, I crunched the numbers and it turns out it's buildings, and but we can do better. We can design zero net energy buildings. Let's start now, and we'll gradually get to the year 2030, and then by 2030 we'll be at zero net energy for new construction and all of our renovations. And so for me, I was both alarmed and inspired, and it actually, in that moment, changed the trajectory of my career. So yeah, so I do get to do green building all the time now. So with that, fast forward a few more years, and we had a group of architects at the AIA, and we wanted to bring in a speaker series that would have all of the great content of how to actually design zero net energy buildings. And so we adopted this this program, and it was out of Architecture 2030, called the AIA 2030 plus AIA Professional Education Series, and it turns out that was developed by our speaker today, Vincent Martinez, who had worked with other ones and brought it here, and so we introduced that that program. And Vince came out to be a part of the presentation, definitely the highlight of the series. So keep going. Here we are at our speaker today. Vince Martinez is honorary AIA and the president and COO now of Architecture 2030. He's been with that organization 18 years and just has a wealth of knowledge and obviously a commitment to a broader view, as you will see, of this Architecture 2030 as a think tank for all kinds of climate action, resiliency kinds of issues. And Vince has been, he's a global leader. He's been part of leading across the nation and internationally to be able to be a part of climate conversations. So super excited. Thankfully, he likes San Luis Obispo, a lot of connections at Cal Poly architecture program. So he was gracious in agreeing to be with us here today. So with that, Vince Martinez.
All right, thank you, Andy and Jim and Greg and everybody else who's supported and helped bring me here. I jumped at the chance when Andy emailed our office and it came to our info email and said, would anybody from Architecture 2030 like to come to SLO? I immediately said, I will do it. Get out of my way, I'm coming to SLO. So I'm really happy to be back here. It's been about 15 or 16 years, so I'm really excited to be here and spend some time with all of you, and I've got a couple days, so if I don't have a lot of plans tomorrow, I might do a bike tour, so there's plenty of time. But I'll give a little bit of background too about Architecture 2030 before I launch into the theme of today's presentation, because there's a lot we could talk about. And when I spent about an hour and a half probably talking with Andy and said, like, here's all the things we're working on, what is it that you think would be relevant to your audiences? And I am going to speak to that, and which is mostly around beyond buildings and the exterior built environment. But I want to give you a little bit of background on who we are beyond what Andy said, that we're a think tank, we're thought leadership, and we're led by design. Our founder and CEO, he was a professional architect and educator and author for 35 years. This was an encore career for him. He could have retired, but he said, no, I'm going to start this nonprofit, and I'm going to make sure that people understand they have to be empowered, that the design profession can really lead us forward. So we always take the lead in focusing on design. And we do focus on professional commitments. So we worked with AIA as an example, what Andy brought up, industry organizations, but we also work in public policy. And we think that public policy works really well, our theory of change, when it's informed by the design community and the professionals that will have to follow those regulations and policies. And so it's a circle, but practitioners can actually lead quite a bit, and then the regulations can follow, and then we lead and we move forward again. And we've done that, and I'm going to show you some of the success stories, but we do lead through design. So I'm going to focus my presentation primarily on pretty underrepresented acknowledgement of the contributions to climate change of the exterior built environment. Just like we didn't understand buildings, we didn't really understand the exterior built environment's impact either. But also where there are tremendous opportunities, not just for mitigation, but for adaptation. And we can do both if we lead with nature-based solutions. And I'll talk a little bit about that. Nature-based solutions are one of those terms that everybody knows, but nobody actually knows what they mean because they all mean something different. So I'll tell you what I mean when I talk about nature-based solutions throughout the presentation. But first I want to talk about how can we actually make change. And where have we seen a tremendous success story here in the United States, and then now we're starting to see globally, particularly around building sector operating emissions. So when we started our organization, the name Architecture is in there, the name 2030 is in there. As Andy mentioned, that was the date in which we wanted to see all new buildings be net zero, or we called them carbon neutral actually back then in 2006, which meant they were very efficient to operate and they were powered by renewables and had no fossil fuels on site. Well, that was a novel concept back then. Maybe we understood energy efficiency from the energy crisis in the 70s and then into the 80s. But renewable energy was just starting to take off, and we didn't even think about on-site fossil fuels that much. However, every little building had a little power plant that was having emissions from its natural gas, and now we're talking about that. But at that time, gas was a bridge fuel for climate. We weren't talking about zero. We were talking about 80 by 50 maybe at most, 80% reduction by 2050. But, and this was really fascinating. This is how we got started. We looked at data and we said, as we grew our built environment, since the dawn of the Industrial Revolution, we increased our energy consumption, and with our energy consumption, we increased our emissions. And this was the trajectory. I could go further back if we had the data, but I'm showing 1995 to 2005 when we launched the 2030 Challenge. And this is what it looked like. Now I'm going to fast forward to 2005 to today, and this is how much building we keep adding to our building stock. We've added essentially 44 cities the size of Chicago to the US building stock. Increased our building stock by 70 billion square feet. That's a lot of buildings, right? And in a short period of time too, by the way. This is 19 years, about the same time that I started working at Architecture 2030, we built 44 Chicagos. Holy smoke. We're gonna talk a little bit about this growth pattern piece. But look what happened. Starting in 2005, on a dime, instead of going straight through the roof, we started leveling things out and actually have reduced energy consumption in US building operations by 16%. It's because we're designing buildings to be more energy efficient. We're renovating buildings to be more energy efficient. This is both design and policy allowed us to do this. But how quickly that changed? How quickly? Because we woke up and we said this is a problem and we want to do something about it. And it didn't matter who was in the White House. This trajectory continued and moved forward under Republican and Democratic administrations. It didn't matter. It didn't change the flow. And we see the movement of the modern movement as a great example of architecture, how we had the international style in the 1920s to the 1940s. We changed the face of the planet, the way the built environment was constructed in a very short period of time. But what's even more exciting than that drop in energy consumption is the drop in emissions. 32%. So when people say you get depressed, or we're not making progress, if you look at the numbers for US building sector operations, this is our heating, our lighting, our cooling, our plug loads, everything we use to keep the lights on, we've actually reduced emissions from 2005 levels by 32% at the same time as building 44 Chicagos. That's tremendous. That's amazing to decouple the growth of the built environment from operating emissions. But we're not talking about all the other pieces, and I'll get to those, because there's materials and there's the growth pattern and how much we're actually building. But in terms of operations, we've wanted to fix it. We're making progress. We're on track to the Paris Agreement for our sector. And look, this is just some of the numbers. This is CO2 intensity. This is how much CO2 we use per energy in buildings. Almost 50% reduction already in commercial buildings over the last 18 years. And 40% in residential buildings. And a big part of that is due to the fact, of course, that we are decarbonizing the electricity grid. This is 2010 to 2024 for the US, 32%. Mostly, look at all that coal. We've gotten rid of most of that coal at 47%. But it's not just about the energy the profile of the electricity grid. It's because we're doing great work in the design and construction field. And now globally, this is how it looks. 35% increase globally since 2010 in terms of our global footprint. That's the equivalent, I mentioned 44 Chicagos in the US, 2 United States globally. Now we were the ones that coined the phrase that we build, or projected to build, I should say, the entire footprint of New York City every month for the next 40 years. It's the size of Paris every week. And so, plenty of work for you all if you're in the architecture and engineering fields, but a huge footprint impact. And a lot of this is happening in Southeast Asia and Africa, which has an extremely young population. Latin America, we're still building in North America, and we'll still build a bit more, but it's happening in these other regions. And what's interesting to see, the globe is starting to follow a similar pattern to the US. And what we've done over the last 18 years is we're starting to level out energy use. We're not climbing as fast as we're climbing in our growth. We're getting more energy efficient, and this is emissions. We're actually down globally 4.4%, sorry, correct that if you're reading the recording, 4.4% of our CO2 emissions from building operations. So it's a huge success story. We're starting to bend the curve down. We got to go faster, and we got to go there. But when we put our mind to something, we can do it. Again, big part of this is due to the electricity grid globally. Look at that. 33% non-CO2, now we're at 55%, and that's because solar and wind are just taking off like crazy. We've had more solar investments than every year than all other energy sources combined for at least 5 years. We hit the transition mark a while back that all the new generation was renewable. So we're on a good track. So we're still responsible though for 27% in buildings of annual operating emissions. And it's made up from a variety of just subsectors. But more importantly, what I want to talk to you today about is the materials. So this is also called embodied carbon. It's the extraction, the manufacturing, and the construction of built projects. So we're talking about buildings here. It's about 7.7%. This is just the high intensity materials, essentially four materials. Steel, aluminum, and concrete. It's three. They kind of do steel and aluminum separately. But in addition to buildings, those high impact materials go into infrastructure. We don't really think about that a lot. I mean, a lot of the policies are devoted to buildings. We have a lot of great design going on. We have design thinking, structural optimization. We've got low carbon concrete. You've got mass timber designs, things like that. How are we affecting infrastructure? And when we talk about the growth of infrastructure, which I'll get to, it's even more dramatic than in New York City every month for 40 years. So when we think about this, let's break this down a little bit. This 15% that goes into materials, where do they go? This is, on the far left, is cement. Half of the cement goes to buildings, half of the cement goes to infrastructure. That's fascinating. We think about it, it's under our feet right now. We're in a building, but it's under our feet outside too. Iron and steel, it's about a quarter going to each one. And then aluminum, about the same. We actually use more aluminum in our infrastructure. I won't go into the whole tariff piece conversations about these, but affecting our infrastructure significantly. And that's just the high impact materials that we know about, that we have data because they're so large, that they're so all consuming, we can actually understand what they are. We know the asphalt, for example, is a huge infrastructure material, and we have zero data for it. We have very little information about how much asphalt we use, what its energy consumption is, what its emission profiles are across the globe. We just don't have that aggregated data. So we know a good portion of this other industry, this other 22%, is industrial products that go into our infrastructure. Could be piping and roadways, all sorts of things. This is the staggering statistic. I told you the New York City every month for 40 years in terms of buildings. Though the UN Secretary General says that we are actually, the infrastructure needs of our population of the globe in the year 2050, 75% has yet to be built. I think about that as we're going to do 4 times the infrastructure that we have right now. And where is this happening? Well, it's mostly happening in developing countries. It's where they don't have the infrastructure that they need to support the growing populations. Some of it, of course, will happen here still, and a lot of this will be torn down or rebuilt. There's a variety of different ways, but 4 times in a short period of time, it's just mind-boggling. So we know that even if we get a handle on operating emissions, which I think we will, we're going to burn up our carbon budget like that, with all of this material that goes into our infrastructure and our buildings. So how do we get a handle on this? And even more so, a lot of urban planners, and I'm sure there's some in the room, we think about our planning decisions is focusing on vehicle miles traveled, right? I mean, depending on how we end up with urban sprawl, we're changing our transportation habits, and there's emission profiles here. So I would argue that the built environment influences an incredible amount of this pie. Certainly more than 40%, which we started talking about 10 years, 20 years ago, but a huge portion, almost nothing is not touched by the built environment. It's amazing to see the reach and influence. So we should really be talking not just about buildings and a focus on that, but the broader built environment. And I know I get the question about Architecture 2030 all the time. Yes, we have architecture in our name. I feel like we should change it to Built Environment 2030 if we're going to change our name. I know 2030 is coming up and we'll deal with that too. But Built Environment is where it's at. And this is interdisciplinary. This still leads with design. We've got infrastructure engineers. We have urban planning. We have landscape architecture, civil engineering. We have all sorts of amazing design disciplines that if we put our minds to this, we can change. But we also have incredible opportunity in the built environment and levers of change that we didn't have in buildings the way we do in infrastructure. So we know, I brought this up earlier, that 30% of global emissions are from urban sprawl. And I'll get into some more details about this in my presentation, but it's a lot of infrastructure to go build out entirely new neighborhoods, all new underground utility systems, all new roadways, all new infrastructure above ground for electricity. We also know that buildings are not always designed by architects, but are also designed by planners. They set up the massing, they set up the setbacks. 83% of the emissions are locked in the planning stage. Orientation, this is phenomenal about how planners can actually affect building design, and we don't think about that and how we leverage it. I mentioned the fact of 4 times the infrastructure to be built over the next 25 years. And that we know where those emissions are coming from. They're coming from the materials. I showed you that in the concrete and steel and aluminum. And we have the data to back it up. We have thousands of infrastructure types of projects. We see that all the emissions are happening. About 75 to 90% of the emissions are coming from the materials. But yet, the natural environment and nature-based solutions that I'm talking about have an incredible opportunity for drawdown effect as well. We're talking about vegetative soils, being able to draw down and pull CO2 out of the atmosphere. About 30% of the drawdown needs by 2030 could be met with these ecosystem sequestration services. And we also know that we're making tremendous amounts of investment into infrastructure. Of course, we're going to build all that. I mentioned that, but the numbers are staggering. It's about $90 trillion in major infrastructure projects between now and 2030. That's 5 years, and it's $90 trillion. That's the World Wildlife Fund stat. And we know that of the funding that's going into those projects, less than 10% is for green infrastructure projects, even though they cost about 70% less and perform similar functions. And a big part of that is because we don't have quantifiable data on nature-based solutions and infrastructure. And so municipalities and other jurisdictions are hesitant to try to engage with those because they end up getting value engineered out because they don't have the data to prove that they can meet the same things that the hard infrastructure can do. But we also know that we have these co-benefits. We know that we have urban heat island effects that nature-based solutions in urban environments can protect against, reducing the amount of heat by, even if it's 5 degrees in temperature, can make it feel 15 degrees cooler. Just by planting trees, just by having these opportunities in our built environment. We know that flooding is one of the major issues for resiliency across cities across the world. 80 million people will be affected by flooding, coastal flooding by 2050. We have living levee opportunities with it in infrastructure, constructed wetlands that can help meet these with nature-based solutions that are less carbon intensive. We know that these support water use, which is a huge part of the energy-water nexus, and that they can support biodiversity. As much as we talk about the climate crisis, we're in a biodiversity crisis as well. There's separate COPs in the UN environment programs around these different programs. These are part of the same conversation if we focus on nature-based solutions. And we know that our more equitable communities are brought in with nature-based solutions, not just the heat aspect, but air quality as well, access to open space. These are really critical elements. So Architecture 2030 over the last 2 years has had funding from the Climate Works Foundation to support climate positive design of the exterior built environment with a focus on landscapes and infrastructure. And as part of that, we evaluated climate action plans from a variety of different sources and disciplines, and ones that were in place right now. Many folks are starting with their second wave or third wave of revising their climate action plans. And what we found is that there is a shift to move from more mitigation-focused strategies in many local municipalities into adaptation. We're at that point. I remember when Ed, our founder, was sitting next to Dr. James Hansen, and he said, when are we going to start seeing all of these impacts of climate change? And he said, when we reach 1.5. Well, we're pretty much there. 1.3, 1.5. We're here. And so we need to be thinking about both of these together. And that's the amazing part about nature-based solutions, is they are both an adaptation strategy and a mitigation strategy. So we have to think about how our climate action plans address both. In fact, I'm going to be a reviewer on the American Society of Landscape Architects Biodiversity and Climate Action Plan, BCAPS. So we might even think bigger and bolder about what this means and what solutions meet. We also know, again, nature-based solutions can meet that, and that we need to think of it across all scales. This is not about just buildings, and I put a resilient building in an unresilient place. That's not going to work. We have to think at the urban and the regional scale. We also spent over the last 2 years trying to understand the impact of urban planning decisions on embodied carbon emissions. So around how do we reduce the impact of that concrete and the steel that we're putting in? I mean, half the concrete, a quarter of the steel, a quarter of the aluminum. How do we reduce the amount that we need? How can we leverage design thinking? How can we affect planning to do this? And we lead with a sufficiency mindset. And sufficiency, I'll talk about in a minute, is a part of a three-legged stool from the IPCC and from the UN framework. There we're familiar with efficiency. We have energy input. How do we get the most out of that in its output? We're familiar with renewables. How do we power that energy with renewable and non-carbon sources? Sufficiency is how do we reduce the demand for energy, land, and water, and other vital resources. How do we reduce the demand? It changes our thinking. It makes this question, the idea is that if we should build. And we'll dive in a little bit to this. So we start there. When should we build? How much should we build? What's enough to meet the needs of the people that we're designing for? Where should we build? It matters in terms of our natural environment that's already providing those ecosystem services, that's already doing the carbon sequestration. Greenfield development, should we build there? And then how should we build? And this is where I think, honestly, we've been spending most of our time over the last 20 years thinking about how we should build. And we very rarely ask these questions above. So this is how the presentation is going to be structured here. So first off, if we ask, should we build, we need to understand what we already have. How much embodied carbon have we already invested? I love this project. I love the Butler, where they're keeping me up. I mean, we have existing infrastructure right here in a building, certainly, but we have existing infrastructure that we've invested in our communities. And rather than building a whole new development down the road, how do we leverage the utilities, the connective points, the transportation networks that we already have invested in? I got asked by folks if I wanted to be part of a qualifying team for a building they were going to do in Detroit to help evaluate the architecture firm. And I asked, my very first question is it a new building or are you going to renovate a building? And they said they were going to build a new building in Detroit. It blew my mind. An organization that thought they were doing a sustainably minded design in the city of Detroit, of all places, was not considering just leveraging the existing assets that were there. We have to think about this. But that's buildings. I'm also talking about infrastructure. This project that you can see in that blurry background is the largest development project in the entire EU. It's the Old Athens Airport. It's the landscape architecture firm is Sasaki on it. They're reusing the entire tarmac, 300,000 pounds of, is it pounds? Let me see. Square feet of concrete. 300,000 square feet of concrete from that tarmac are being used in that project for walls in the landscape projects. It's amazing. This is what we should be doing. Why are we tearing it all up, putting it in a landfill? We should be repurposing it. And this is now becoming a public park. It's part of a stormwater plan. It's part of a coastal sea level rise plan. It's multi-purpose. So not only do we use our existing structures, but we should be using our existing infrastructure. And again, I brought up, I'll leave this up, but this is the sufficiency framework. And I want to talk about this because I think it's really important. Sufficiency is a new word. You're probably going to hear more and more about it. It's going to be like the new sustainability question. But it means two things. It means how much is enough in both directions. At what point are we meeting the needs of our communities and the needs of the people within them? And how do we help elevate them? So when we're talking about a global stage, we're talking about how do we meet the growing populations in the developing world? How do they get the fresh water that they need? How do they get the shelter and the schools and the medical services that they need? If we have a limited amount of carbon budget, it should be used there. And then at the same time, if we've already invested and we've already put up all that emissions from our existing infrastructure, how do we make sure that we're not exceeding planetary boundaries while we bring the rest of the world up? So it's really important. I don't know if you're familiar with Kate Raworth's donut economics. Out of UK, it's a new economic theory. It's very similar to how do we meet the needs of folks without exceeding planetary boundaries. That's what sufficiency means. How much enough is enough. And we have to think about how do we leverage things for multiple purposes? How do we integrate buildings as infrastructure if we're going to do a building project? I was in San Francisco not that long ago. I don't know how many folks have been down there recently, but just next to Salesforce Tower, real big monster of a building, is the new transit hub for the city of San Francisco. All the buses and everything go in there. It's got an elevated roof, green walk pathway. It's got like a little nature park associated with it that has businesses. There's a little brewery on it. Like, how do we do more when we actually have to build? And in addition to that, how do you leverage new buildings? In Australia, they're leveraging a new building to take in all of the storm water and black water from the neighboring surrounding buildings and sites and process it there, because they're already growing, and rather than expanding the capacity of the infrastructure system, how do they think modularly and then add it on through the next building piece? So there's so many examples of this. Ontario particularly has a really great policy where it's a framework where they would give allowances. Usually it's like if you provided a public park or an amenity space, then they'd give you additional floor area for the development. Well, we could do that if they took on additional infrastructure pieces. So then I want to ask, now we say, how much should we build? It's where should we build? Now, growth boundaries traditionally have been a planning tool to help reduce vehicle miles traveled, right? But it's also a tool to make sure that we're not getting into greenfield development, all of the site work that has to be done and tearing up all of the vegetation that's there, that's acting for ecosystem services. These are also making sure that we don't have the sprawl piece that I talked about earlier and adding all of that in new infrastructure. So this should just be an added on value to existing policies and platforms that we already have. And you're saving embodied carbon too. Great, let's do more of this. We also need to make sure that when we do need to expand, that we know where we're going. I was at a World Economic Forum thing the other day, and they had the Minister of Tourism from Saudi Arabia talking about the line. An entire brand new development built just for tourism along the coast, in a line of all the most amazing ways to do new development. It's not going from one place to another. It's not infill. It's brand new. We need to think about how do we integrate and connect the pieces that we already have. We need to think about that in terms of our urban planning. I think we've done a pretty good job, but we could do better. We can make sure that we're going along those paths and we build on those infrastructure. And I'll talk about some of the synergies that we can find. We need to support and prioritize transit-oriented developments. This is, again, not just a vehicle mile travels reduction opportunity, but an opportunity to eliminate the need for new infrastructure if we build in these dense urban environments around transit hubs that connect us between each other. And then those transit hubs can also provide all those other services. I mentioned the building in San Francisco, public park. We can incorporate all of these things as we build. Part of it, though, is I'm starting to see, I live in Seattle, and we have a new light rail system that's expanded up north, and it's great, and I'm seeing great housing development that's going on along that, but you're not seeing the plan for complete neighborhoods. It's just housing right there by the light rail station. There's no amenity, there's no doctor's office, there's no grocery store, there's no coffee shop, there's no tap room. There is in Montlake Terrace, not far from me, which I was really inspired by, but we're just not seeing these types of complete neighborhoods being developed around these transit-oriented developments. We're trying to leverage that, and that's great. This is all part of the 15-minute city. Can I walk or can I bike to everything that I need within 15 minutes? But when we're thinking about, we're not connecting the dots between the housing policies around these transit-oriented developments and the idea of complete streets. We just think people are just gonna get on the light rail and then they'll go into the city. And we're missing the opportunity to build community. We need to identify and protect and enhance natural resources. I brought up a greenfield development. These are things that are providing ecosystem services already for us. And every time we go through there, we're gonna tear it up. We're gonna have all these new equipment that's gonna release emissions that are going in there, and then you have to build all the infrastructure just to do what it was already doing for us, just to process all of our waste. Wetlands are an incredibly valuable and important place for our ecosystems and for us as individuals, for clean air and clean water, and yet we try to replicate them with engineered services when we're tearing them down and replacing them. We also have a great opportunity with urban and peri-urban agriculture and reducing food miles traveled. Where does our food come from? We're understanding all of the complexities of a global trading system. But if we can end up getting more of our food locally, I know the farmers market's going on right behind us, there's a great opportunities, not just in producing food, but also producing vital energy sources like power. There's agrophotovoltaics, where they're combining farming with photovoltaics to produce energy from the rural to the urban. But we've heard about how farmers are keeping their farms by installing solar, not just solar, but wind turbines. There's a lot of opportunity to leverage the agricultural sectors in and around our built environment, where we don't have to rebuild and start over. We don't have to build brand new power plants, as an example. We also, this is the opposite of we should not build in greenfield, but we should leverage the brownfield sites. This can be challenging, I understand that, but these are usually in places that are already directly connected to the urban built environments that they're trying to serve. So when we're looking for land, rather than following a new path, there's stuff that's already got the utilities sector. They're usually pretty big developments. I don't know if you're all familiar with like the Stockholm Royal Seaport. That's in this picture here. So you're seeing this a lot of Navy, Brooklyn Navy Yard. I saw this in Philadelphia. These sort of really key sites, really amazing sites that already have a lot of infrastructure built on them. A lot of small buildings. Some of them have district heating systems and power systems. There's a tremendous opportunity to reconnect those into the vital services of the built environment. Obviously, there are remediation issues that need to happen, but we can use landscape architecture and remediation opportunities with vegetation to clean the soil and actually produce things better. We do have to be careful a little bit with this next piece, which is poor soil conditions. I mean, how often do we have to use carbon-intensive pier systems because we have poor soils or larger footings? And we just, hey, that's where the site was. And that's where we can build. And honestly, that's where we put our affordable housing. We put them in the floodplain. We put them in the cheapest place we possibly can. We need to really consider about where we build. And where we're building can have serious embodied carbon impacts. And I'm going to talk a little bit about below-grade development. But we need to be careful, do an assessment, and see where there is opportunity. It doesn't mean that we shouldn't be building in those places if there's a strong way to do it. But we should do a life cycle assessment to find out what it's really going to take in terms of its emission profile. Okay. So now we looked at where should we build. Now we're going to talk about how we should build. And this is what we're more familiar with. But I want to leave you with leading with nature-based solutions is really, really key. We usually go to sort of the last resort. We say, we'll just put low-carbon concrete in and we'll be good, right? That's our solution set, is to say it's almost like taking the building operations thing and say, we'll just throw solar at this thing and forget about energy efficiency. Where's the design thinking? Where's the opportunities for integration with our other disciplines? If we leverage nature-based solutions, they're very resilient. They've been here for a long time, and we can help and enhance them. I think about constructed wetlands a lot and living levees because we're having so much of the world prone to rising sea levels. And I think there's a tremendous opportunity for these living levees, which are leveraging the natural environment to help slow down and reduce the sea level rise. We're starting to see those being applied in different places, but they can really do multiple purposes. We also have to think of other resiliency opportunities. Living levees is a great one because resilience to sea level rise. But in so many other cases, we're also affecting the built environment in preparation for other natural disasters. I brought up heating particularly. I think there's a really important interconnection between built environment, decarbonization, and urban heat island effect. I mean, you're all familiar, I imagine, from previous presentations about the benefits of heat pumps. 3 times more efficient than even the most efficient natural gas, no on-site fossil fuels, powered by renewable energy. We've got to worry about the refrigerants. We can talk about that in a different lecture. But great technology. But it's just moving heat around, and we're taking heat out of the building and we're just throwing it right there. And that building's throwing it right there, and that building's throwing it right there, and we walk outside and all of a sudden we're wondering why it's hot. Because we took all the heat out of our buildings and we put it into our urban environment. And we already are dealing with the fact of urban heat island effect from all the materials and the radiative heat. So if we have more vegetative cooling, on buildings. If we look at more urban forestry and tree planting, those help cool off. I mentioned that even a 5-degree temperature can feel 15 degrees cooler with nature-based solutions. So we have to think about this. I got to talk with the executive director of the Resilient Cities Network. I don't know if any of you are familiar with the 100 Resilient Cities thing that the Rockefeller Foundation was doing, spun off into this network of cities all over the world. They're hiring chief heat officers in cities because it's getting so hot and they have no idea what to do. So they're creating cool corridors. I'm really inspired by landscape architects and their ability to meet this need at the city level with these cool corridors. In Thailand, particularly in Bangkok, they've done a tremendous job on this. We need to think about how do we get more out of what we put in. This is the Q line in Detroit. I don't know if you're familiar with that area. I brought up Detroit earlier. But they wanted to build this transportation hub to connect, I think it was Midtown and downtown. And the Quicken Loans guy, I can't remember his name, he owns half Detroit. He decided, well, I'll pay for, basically, I'll help subsidize this transportation line. It's got all the things you want around it. It's got bike lanes and bioswales, it's got all these things. But what they don't tell you is there's a fiber optic line underneath it. I mean, he owns the fiber optic line. That was the trade. I think it's a pretty decent trade. But you're doing multiple things. If you're going to tear up that infrastructure already, do it all at the same time. Don't be piecemealing it and then you have to come back and you're never going to tear it up again. So how do we leverage multi-purpose and adaptable infrastructure? This is a really interesting one about density. I'm curious how this will go in the Q&A conversations. Density is really interesting from an embodied carbon perspective. It's kind of like a Goldilocks thing. Too small of density, we spread out. Like we have all that infrastructure thing that I talked about for the amount of land use. We have new pipes and new roads and new electrical lines. And then as we get really, really dense and we get to the megatall that we see in Southeast Asia and everybody's in a race to the sky, those are actually pretty efficient in terms of its material components per occupant. But they end up using really high embodied carbon types of materials like concrete and steel and just to go higher and higher and the base can't support it. So you've kind of got these two options. So we have this Goldilocks thing. There's a sweet spot in the middle and depending on whose report you read, there's somewhere between, it's 6 stories. No, it can go all the way to 30 stories. It depends on which firm is doing the study. But there's something in the middle and that also is something in the middle is also more livable, which we recognize. People that live in the giant towers, they don't meet their neighbor, they don't know anybody. They also you have to get all the way down. There's the resiliency aspects of that and danger. So there's a sweet spot here when we think about density from an embodied carbons perspective. Related to this that I didn't bring up earlier in the complete neighborhoods piece is the importance of mixed use development. We can't have these office parks and these residential pieces and that's a connection to issue from the transportation emission perspective. But we also have this issue, not just with mixed use, but we need mixed income. And too often do I see policies for affordable housing where the developer can pay into a fund, and then that fund, instead of doing affordable units, and then we create isolation. We separate the folks that don't have it, and guess what? Again, they're building in the floodplain or in the TOD, and then they don't have the services. They have to have the transit pass to even go to the doctor. Like this we're not connecting the dots here. When we think about infrastructure as well, we're going to need these heavy, big pieces of horizontal infrastructure. Transportation is a great example of that. Tunnels, bridges, railways. Like we're not going to avoid these things. They're going to use high amounts of concrete and steel. I'm not a Pollyanna. I'm actually a structural engineer by training. So I know this stuff. It's pretty cool. And it got me excited about it, but we got to mitigate its impact. And there's great opportunities for structural optimization. You can do voids in the slab so you don't have to use as much. It's how structural optimization and efficiency. And there's actually really good policies on this. There's a mandate in both San Francisco, LA, and Seattle all have a just enough evaluation of structural efficiency on infrastructure projects, right? Because so often as an engineer, I can say this, we have factors of safety tables that we look up. It's like 3 or 4 times what we really need. We're just throwing a bunch of concrete and cement at these things just so we make sure that we don't have Hammurabi's code where they cut our hand off when the thing falls down. This is really important from a structural and safety perspective, but we can do better. And then this is part of it, is that this is the icebergs idea. When we do a whole life cycle evaluation on a building, below grade is a huge carbon sink. We've got the digging, we've got the shoring, we've got to line it with high impact concrete. it's huge. It can be, on average, 50% up to 80% of an impact of the entire building structure and substructure is underground. And it doesn't help that we have policies that mandate minimum parking, and then therefore people don't want it, and for urbanism, for good reason, right around the edge of the building or on the bottom floor, and so we dig. And we tunnel down. We also have basements and residential pieces that are sort of sometimes mandated. We feel like we needed to store our stuff in there. How do we think differently about these design parameters to say, yeah, maybe we can avoid minimum parking, which is actually the next slide. Or we can be careful about how much underground development we have and be careful with the fill and move and the cut and fill. But it's really, we're starting to see more policies moving from parking minimums to parking maximums. And this is a strategy that requires integration with urban planning and transportation decisions. You can't just force everybody to get out of their cars and you don't provide any infrastructure about where they're going to go. So we have to think about these holistically. And then there's also opportunities to leverage our material choices. When we have to use them, what do we think? There's the Athens airport example. We're going to tear up the tarmac, and we're going to use that in the building and the landscape project. Awesome project. I can't talk about that thing enough. There's another great one that's in the Bay Area that's happening that's very similar. It's called Depave Park. Now, so we got to use what we have on site. We can find salvaged materials either on site or locally or nearby. There can be challenges with structural reuse of existing materials. And then we have to think about how do we leverage biomaterials. This is a footbridge that's connecting an area in the High Line in New York, which was designed by SOM. It's going to use vast timber elements. It's going to withstand the weather implications of the New York climate. Like, we can think differently. We can start leveraging different building typology. We used to build bridges out of wood. The Brooklyn Bridge was made out of wood on the decking. And in fact, even the pier systems of the Brooklyn Bridge were made out of wood. Oh, what did I miss? Okay. And then I wanted to sort of, one of my closing, I'll move on from that, elements is that we are now in a technological revolution. Big rigs have gone electric. We can be having all the construction equipment coming out of Volvo and others that it's all electric now. Pretty high intensity stuff. What's really, in mining, they're using these all the time because they go down, they have to go into the pits, they're pulling things out. They have the regenerative braking on the way down. They power up all of the energy they need in the battery, they fill the thing up and they drive all the way out. They're depleted, they drive down, they redo the regenerative braking. I got to borrow, where's Jim? Jim's Golf EV cruise around town today. Like, we're in a new way of even building buildings and infrastructure. We can use these technologies and we can have on-site renewables to power them. So in my closing up, I'm going to show you a few resources besides the framework that I pulled these from. Architecture 2030 has been compiling pockets of the future that are alive and thriving in the present. Where are the projects that we want to see replicated, and what elements have they already implemented? When we have a really complex problem, we pick ideas that are lying on the ground to solve them because they're so immediate and so fast. We need to know exactly what we want. We got the world that we envisioned back in the 1920s with the international style, and that's why every building looks the same regardless of climate zone. They presented at the 1936 World's Fair in New York. I might get the date wrong a little bit, but pretty close. The city of the future. It looks like Dubai, and that's what we got. We designed that. We knew what we want. We don't have a design vision for the future well enough. This is an attempt to do that. We're visual people in the design community. We want to see what this looks like. So we looked at things not just at the building level, but all the way at the region and planning level. So we did a lot of inundation mapping and hazard mapping pieces. We looked at transit-oriented developments, smart 15-minute cities, site infrastructure, vegetative cooling, and then we have all the building strategies that you're probably familiar with and heard from a variety of other presenters on passive cooling and daylighting and natural ventilation. But I pulled up just this plan, regional, district, and site, regional, city, and district strategies. There's 35 of them, and they have great examples of who's been doing this around the world, what policies they implemented, how successful they are, and what the rules of thumb are. You don't need to do all the research. I mean, we've got AI tools now that'll crunch all the reports. Like, what are the top 5 things we should be doing here? What should be incorporated into your BCAP, your Biodiversity and Climate Action Plan? We know what they are. We know the strategies. Let's just get to work. And I want to leave you with something a colleague of mine wrote in a report. He was doing the systems thinking workshop. And I've been thinking about systems change for a long time, but I couldn't really quite articulate what I was trying to think about and how to share that with folks. And he had this, so I'll read it because I think it's so well written. He said, this is really important actually for me as an NGO, because NGOs are a little different than, we're mission-based, we can collaborate, and we don't. The unspoken reality of mission-driven organizations working in the same space as each other, sustainable built environment, for example, is that most of them have neglected to intentionally design the interconnections with one another, roles and relationships that will produce an order of magnitude change and impact. Instead, we find that duplication, ignorance, ambivalence, role confusion, and even direct competition between organizations is more common than well-designed systematic collaboration. So it's the difference between cutting down a bunch of trees and strapping them together and getting a rudimentary raft, or designing a really amazing vessel that we can all share and participate together. But we have to know what each other are doing. We have to think about the ramifications of our work and what other people are doing. So I leave you with that. I'm sure if we had more time, we could throw some yarn around and connect each other about where we're passionate and what we're doing. I like doing that kind of example. But here's some of the resources, and I think they're going to share them in the presentation material. And I'm really looking forward to the discussion, which is why I walked through that as quickly as I could. Okay, awesome. Thank you.
Bill, I forgot to ask for a second microphone when you get a chance. Thank you. Thank you so much. Amazing, inspiring. I'm renewed all over again. I have a couple of questions that we're going to start with, and then we'll open it up for folks so you can start to do your questions as well.
Thanks, Bill.
Great, thanks. So I think there's so many takeaways, and I can't wait to look at the resources, but one that popped out pretty quickly is the agriculture piece, because we are surrounded by agriculture. We're an agriculture-rich community, and for everything, crops, regular, but also obviously the wine industry, increasingly citrus, etc. And I remember thinking about the struggles of farmers, and is there a market for carbon selling carbon sequestration credits, or the PV wind farm example. But any suggestions on kind of proposals that might be that might fit a kind of scale where you have a whole bunch of different farmers, but hey, here's the kind of thing that we could do to have better carbon, healthy soils, natural solutions, and have it be affordable to farming community that struggles.
Right. Well, that's a great question. I don't have a lot of expertise in this, but I'll give it my best shot, and I'll share an example of something I think is pretty interesting. But I think the connective piece is the real challenge, and you have different lobbying industries trying to make carbon credits work, and they're not always the same. They look at durability, and what is that going to happen without additionality, is it going to happen without my funding? Is it going to be there? Can I count on it? Am I just throwing money out the window, like when I sign on a flight and I click, I'll take the green option. What are they even doing with that? What transparency? I think we've seen a lot of design firms really look for that kind of credible piece, and the agricultural sectors in general, including forestry, are really looking at this. One of the challenges that they have is showing their day-to-day operations different from the sort of the additionality. What would I do differently? And valuing that, particularly in the forest industry, when the reason why you make cuts might be a new inheritance, a new family sort of took over the family forest, and it was time to do the harvesting. And there's questions about what's the long-term rotation of the crops, and you want them to grow longer so that they have the excess carbon. Somebody's got to pay for that. They need to make their money. They need to cut it down, and to make the delta that they need to keep those plants there, or to do the biochar or the other types of remediation in agriculture. It takes the credit market, but we haven't developed those yet enough. So we're really reliant on the industry organizations that represent those to help validate and show case study examples. I think we need more precedents to say we've done the research and we show it, but we also need to take risks. So I don't want to say that those carbon offsets don't mean anything, because they can, and you have to just try them on smaller applications. The other piece, there's sort of two innovative stories I'll share on the agro side. One is that we're starting to use biochars in our concrete. And so that's a real fascinating one. I don't know if you've seen any of these companies that are trying to sequester carbon in their concrete. Some of them are ejecting CO2 and other things, and that ends up being more of a cement replacement. But the ones that are actually using biochar is a great agro piece. We also have the urban-rural connection with mass timber is a great example, and making sure that we use those. So how do we leverage agricultural byproducts also in our built environment? And it's more prevalent, I think, in buildings. Like we used to use cork for insulation. We're looking at really highly dense impacted straw insulation products that are being bought by some of the biggest manufacturers out there. Saint-Gobain, I don't know if you're familiar with that name. They're a French company. They're the biggest material supplier company you've never heard of. They got their claim to fame doing the windows for Versailles 300 years ago. Well, they bought two really innovative straw panel insulation companies. So they're not just invested in foam, they want to change too, and that's when we'll get more of the big changes of how do we draw that. The other thing that is interesting, I flew to Dubai, which is very strange, for the climate conference, very strange, about 14 months ago. And on the flight on Emirates Air, they told me that the salad I was eating was actually grown in an urban ag environment in Dubai. And because they were having to import things from California, this is the global supply chain, and they keep it fresh and all the carbon emissions associated with it. But the advancements that they're making in urban ag, in very dense environments is actually pretty amazing. So, I'm not saying we're going to get all of our microgreens, but some of the boutique places in Dubai are.
Yeah, awesome. All right, and my last one, at least for now, and then we'll see the other conversation. But I know that you had a chance to speak with some students at Cal Poly earlier today, and so thinking about, well, I was going to say young people, but it's really all of us, about kind of climate angst. You opened with some great information about, like, hey, we're doing well on this. I mean, where do you feel like, what gives you hope? What do you tell young people in particular when you see the concerns that we all have?
And honestly, it's who I tell everybody. I tell my neighbors or my kids' teachers, when they find out what you do and you work on climate, it's always like, well, thank you, and that must be so difficult, and don't you get depressed? Yeah. But then when I just start talking, and then they're like, wow, I didn't realize we're making so much change. And there's a great Paul Hawkins quote. I don't know if you know Paul Hawkins, an environmental writer. He says, if you read the science and you talk to the scientists, you can't help but be depressed. But if you talk to the people that are innovating and working on the solutions, you can't help but be optimistic. And I have that opportunity to talk to the folks, particularly in the design field, that are doing just tremendous work that may not be, their neighbor may not be aware of, that they're a climate hero. And they're doing really incredible things that are having an impact, and we can see that at the aggregated level. So you have to be able to tell those stories. You have to make them real to people so they can see them and they can feel them. And that's what gives me hope, is just working with so many amazing people. And then we're trying to elevate those people to share their stories across the globe, because that's what really will catalyze change.
All right. Questions? Does anybody have any questions that they want? All right, in the back here.
My mind was swimming the first 10 minutes, now it's flooded. But I wanted to ask, as I get older, I get more and more interested in scaling. And so let's apply it to heat processing, heat morbidity. I mean, it's growing exponentially, and do work in the Central Valley and a lot of farms. So how do we provide buildings that cool people off, and these whole systems, and how do we scale it? Right. Using design.
Yeah, I think it's really about the power of landscape architecture. If your firm doesn't work with amazing landscape architectures, you sure should. And we're going to see more vegetative cooling approaches at the building scale and between the building scale and the right-of-way, but it's really hard. It's really hard to, there's a great landscape architecture quote, and I can't remember exactly who gave it, but it's something about finding the crack. That even in a crack in the sidewalk, the plants will grow and they will find their way, and we need to find those types of cracks within our systems of policies and our opportunities for interventions. But to me, that's a nature-based solution. And this is a really scary thing too. If you go to India, you will see buildings just flooded with little AC coolers throughout the roof. it's the cooling load demands that they're expecting from all of this hot climate, already the hot climates now getting hotter, cool climates now getting hotter. The air conditioning loads, I live in Seattle, nobody had air conditioning, now everybody's got air conditioning. Well, heat pumps, cool pumps, I call them now. But that's got its own ramifications. We can't have technological fixes get us out of this. There are design solutions. People have been living in hot, humid climates, hot, dry climates for millennia. Like, we know how to live in those places. We know how to do evaporative cooling. Go watch Dune 2 if you haven't seen it. I mean, it's amazing how much we leave on the table about how we can cool ourselves off and how we can leverage our natural resources in water. And we're just leaving it on the table without the help of the landscape architects. So go find them, make friends with them.
Yeah, I appreciate having naming of things, right? So we can start to have common language, cooling corridors.
Yep.
Yeah,
that's right.
It's great.
Cool pumps. I still think they should be called cool pumps.
Yeah. Great talk. Thank you so much for coming. And since it was 17 years ago, you said, we need air conditioning now too.
You do.
We didn't before. So.
Yeah.
And thanks for bringing the international perspective in. And the question I have for you is, for those of us in the design, building, construction world, here in California, we exist in kind of a bubble. We all feel like we're pretty groovy, I suppose. And how would you compare the state of our design community and the awareness and the things that you're talking about with the international scene? You brought in the Athens example, you talked about Bangkok, but then India as well. So it's probably a mixed bag, but if you can do some kind of comparison there, that would be interesting.
I think it's always easy to have FOMO that, we're not doing enough, the Europeans are ahead, and then when you talk to the Europeans, they're like, oh, you're way ahead, and then you go to Thailand and you're like, oh my gosh, look at all these cool corridors, and they haven't figured out, because they've lived in it, they've already dealt with it. So I think there are these pockets of the future alive and thriving in the present everywhere, and people are really doing amazing things. I wouldn't say that, I think we're very bureaucratic. I think that's probably one of our most difficult challenges in the United States, is the time it takes to make change and to move things forward. I mean, I used to live in California for only 1 year, but it was very bureaucratic here. And whereas you need innovation, and innovation doesn't thrive very well with bureaucracy. But we have to be willing to make mistakes and take risks. And I think designers are good at taking risks. I mean, you deal with complexity every day and you try to mold it into something unique. Engineers, not so good at taking risks. I told you about factors of safety. I mean, but we need to bring them along and help them take risks too. Trust in nature-based solutions and infrastructure. Show them the data to back it up. And you might have to do it on a smaller project. Show them the bioswale. Then show them the next largest segment. Show them the examples, but we always want to see that it worked here and that it worked exactly the way that the other systems work. But that's not how it's going to be. There's going to have to be a give and take about how these things work. We're starting a new project. This was one that, on the exterior built environment, but our big thing is sufficiency, which I brought up, and also traditional knowledge. Like I said, people have been living in these hot climates for a long time. What can we learn from them? We've been focused way too much on exporting global north ideas that are highly consumptive, resource consumption, and contribute to emissions. Our urban planning scales we've exported to. The international style came out of Europe to the global south and to the Middle East. That's why we have the glass boxes in the desert. We need to learn about how they lived before the age of fossil fuels and adapt those into a modern context. And that is it's a shift. It's learning from Southern heritage cultural aspects and applying those in a modern context. So I think we have a lot to learn from everybody, but we got to find where it's going to apply, and it's all going to come locally too.
Your comment about the Athens project, recycling concrete, brought to mind something that is a subject for a local field trip if anyone feels inclined. Go over to Mission Plaza, take a walk along the creek, and look at the retaining wall. The retaining wall is made up of broken concrete that used to be Monterey Street, right adjacent to it. In 1970, Alex Madonna broke up the street and volunteers stacked that wall. So it's a local example of recycling that I think is pretty remarkable. So if you have a chance, take a walk over there and take a look at it.
Cool, I'm gonna go on a bike ride, so I'll cruise through there tomorrow. But it's also great, the application is just as important, which is that community aspect of it. Everybody contributed making that happen.
Didn't Brazil create a city that is based on...
It's based on the modern principles. Brasilia?
Yeah, they put landscape around the whole city and cooled it off by, I don't know, a lot of degrees. And
Yeah, that's an interesting example. So if you're not familiar with the modern design principles that came out of the Congress for Modern Architecture, CIM, in the 1920s, there was both architectural principles where we got the column wall separation, and that's how we got bigger open spaces. We got the windows connecting. That's why we ended up moving to horizontal windows instead of vertical windows. There's a couple of those pieces, but there was planning principles too. And they applied them in the city called Brasilia. And I don't know all the details, but I think one of the challenging pieces of that is while we have vegetation, we still have things very separated and far apart. One of the big principles that came out of the modern movement was about separating the factories, which were super pollutive, from the housing, because people were dying. You know, they were in squalor, and it wasn't a good situation, particularly in Europe. So they created this separation between the two that was part of those principles. And I think that's where now we're running into office parks and residential as an example of that. And you know, we don't have this polluting industry. We still do in certain places. It's pretty bad in Detroit again. But connecting those, so I'm not sure that the modern principles for planning that were adapted there would still apply. I'd have to go back and look. We did write an article about 5 planning principles that are pulled from some of these examples. So I'd be curious, and the palette shows some of those. I don't think anybody's ever going to get it 100% right, but how can we learn about the pieces that are really working and thriving?
All right. Oh, we got a couple more. All right. Let's finish that. We'll take this one in the back.
Hey, I'm an architect in town. I work on affordable housing primarily.
Oh, okay.
This is good. Okay, I was wondering, it seems like a lot of your nature-based solutions are focused on things that maybe right now our building code or our zoning code dictate. And so I was wondering what kind of changes you're seeing that are allowing these innovative solutions to continue.
That's a great question. I shared a couple examples of where these things have worked, and I have more detail about them in the framework, so that QR code would give not just project examples, but policy examples. And policy examples have allowed some of the projects to happen, and sometimes they happen concurrently to make it work. I was on a webinar for C40 Cities industry partnership where they brought in designers at the Depaved Park, and they said most of the challenge was changing the policies in certain regions. So, you know, we have to become advocates and citizen architects or citizen landscape architects or citizen planners in that and get involved in that conversation to open that up. And it might mean starting small and showing proof of concept and then growing. But I think the process is somebody's paved the way, or not paved, depaved the way. Somebody's depaved the way and trying to plan the way, try to find that. But it does take a lot of effort because there's a lot of people competing for the right of way and the streetscape. And that is where we have the most opportunity, because we're very few opportunities come between buildings. So you're doing it piece by piece by piece. But if you can really get at the right of way pieces, you can make a huge impact. So I don't have the examples are in the policy brief that would help you more to guide you.
Which reminds me of your kind of that closing the quote about the collaboration, because I would imagine for our region that the cities and the county all working together at a good scale to be able to work on policy and proof of concept and those types of things.
Right. Yeah. And I think the bioswale one is just a great small example. When we talk about vegetative roofs and stormwater retention, it's like they could have easily said, well, just make the pipe bigger and deal, you know, but we tried to show a different multi-pronged solution. And I think that's also part of it. It's not just dealing with the stormwater, it's creating a mini park. It's creating cleaner air in that area of town, which might have had really bad air. So you have to play on all those co-benefit pieces that I brought up before. Honestly, one of the biggest flips in my mind in my work over the last 10 years is not coming at things through a climate mitigation lens. It's coming at them through all of the co-benefits that people are actually caring about and saying, oh, by the way, we can get lower carbon on that too. Did you know that?
Yeah.
But supporting their goals and their vision has been tremendous.
Different opportunities for funding
Yeah.
as well. All right,
We had one more here.
last question,
You've been
and
waiting.
then we'll call it.
We've been talking about reusing infrastructure materials that are already in place to prevent them getting to landfills. I was wondering if there's a focus or if you've seen examples of trying to harvest those materials that have already made it to landfills.
Ooh. Not as much, and there are some laws and policies that are about recycled concrete, and they go sit in a holding place. They don't get all the way to landfill and pull them out. Salvage yards, there's reuse stores, but they're capturing before they hit that. So it's all about the stream and finding them. We're seeing people doing this at the building scale even before it hits the stream. A lot of people over order, like acoustic tiles or whatever it is, and then they're sitting on them, and then those go in the landfill or old doors. But they're capturing those. It's mostly in urban and dense urban environments where you store it, and how do you keep it, and then some of the structural materials like old I-beams or mass timber pieces. It's like, can you trust the structural integrity of that? And you have to do tests, and does that add costs? So we got to figure out those. But people are looking at material banks. I don't know if you've heard that concept. It's essentially, you know, every building needs to be inventoried. What do we have? If you're going to tear it down, I want to know everything that's in there that I might be able to reuse, and then it's about timing with the next project that it's going to be used for. I actually think that the salvage piece has the largest opportunity in landscape design, because it's non-structural for the most part. I mean, some retaining walls, you don't want them to fall down and like get in the bike path or anything else. But you know, it's not a life or death situation for most of that material reuse. It's not a big bridge and that kind of thing. And so you can innovate and you can try things and you can test performance really well with those kind of things, as opposed to, I'm gonna harvest an old I-beam. Most steel gets recycled anyway. I mean, I think it's like it's like 99%. Like almost nothing stays in a landfill. It's steel. They'll bring a huge magnet in there and suck it out, because it's all recycled steel. That's how all of our rebar in the Northwest is made. The concrete is mostly ground up, could be used for pavements and pathways. So I feel like there's opportunities to do a good job. We're not doing enough, but those materials are very easily reused, even if they're downgraded. The really difficult part is using them at their original intended purpose.
Let's give it up for Vincent Martinez.
Thank you all. And I'll be here to talk more.